But before we get to independence, let's practice once more the 3 skills that we covered last time on this example. So first skill was multiplication rule. How do you find the probability of several things happening? That is the probability that we have tails followed by heads followed by tails. So here we're talking about this particular outcome here, tails followed by heads followed by tails. And the way we calculate such a probability is by multiplying conditional probabilities along the path that takes us to this outcome. And so these conditional probabilities are recorded here. So it's going to be 1 minus p times 1 minus p. So this is the multiplication rule. Second question is, how do we find the probability of a mildly complicated event? So the event of interest here that I wrote down is the probability that in the 3 tosses we had a total of 1 head, exactly 1 head. This is an event that can happen in multiple ways. It happens here, it happens here, and it also happens here. So we want to find the total probability of the event consisting of these 3 outcomes. What do? We just add the probabilities of each individual outcome. How do we find the probability of an individual outcome? Well, that's what we just did. Now, notice that this outcome has probability p times 1 minus p squared. That one should not be there. So where is it? It's this one. Okay. So the probability of this outcome is 1 minus p times 1 minus p, the same probability. And finally, this one is again 1 minus p squared times p. So this event of 1 head can happen in 3 ways. And each one of those 3 ways has the same probability of occurring. And this is the answer. And finally, the last thing that we learned how to do is to use the Bayes rule to make an inference. So somebody tells you that there was exactly 1 head in your 3 tosses. What is the probability that the first toss resulted in heads? Okay, I guess you can guess the answer here. If I tell you that there were 3 tosses, 1 of them was heads, where was that head? In the first, the second, or the third? Well, by symmetry, they should all be equally likely. So there should be probability just 1/3 that head occurred in the first toss. Let's check our intuition using the definitions. So definition of conditional probability tells us the probability of the conditional probability is the probability of both things happening. First toss is heads, and we have exactly 1 head divided by the probability of 1 head. What is the probability that the first toss is heads and we have exactly 1 head? This is the same as the event heads, tails, tails. If I tell you that the first is heads and there's only 1 head, it means that the others are tails. So this is the probability of heads, tails, tails, divided by the probability of 1 head. And we know all these quantities. Probability of heads, tails, tails is p 1 minus p squared. Probability of 1 head is 3 times p 1 minus p squared. So the final answer is 1/3, which is what you should have guessed on intuitive grounds.